Okay, great. So hopefully you got on okay with this. I'll just talk you through the solution now. So here we asked you to get two inputs from the user, get them to input their name and their age, and then to print a message that uses both of these things. So here, we'll look at the bottom one because I've already told you about the SEP thing. So I've got name equals input. What is your name? Now that's going to be read in as a string, so that's absolutely fine. Age. Now that's going to, we want that as an integer, so I'm going to cast that as an integer by putting input how old are you, and then wrapping the int function around that. And then here I'm going to put print happy birthday, comma name. So pull in the whatever value is stored in name. You are, and then pull in whatever value for age today. And then I put the SEP input in just to say leave the spaces how I've got them set out. Did anyone have any problems with any of that? No? Great, fantastic. Okay, so nice, relatively straightforward exercise just to get you started. Now, another important thing to consider whenever you're writing programs, and it's a very good habit to get into right from the start of your programming journey, because it is very easy to ignore this, and it's incredibly important actually. And that is providing comments in our code, and that is leaving notes essentially within our program that explain to others, and frankly to ourselves when we look back over what we've written, what various sections of code are doing, or in some cases what they're supposed to be doing. This makes it easier for others to see what you're trying to do, and also, as I say, for yourself, when you go back to a piece of code and think, why have I done this? It makes it much easier. So sort of you can write in just completely plain language, just explaining leave little notes to yourself and to others to explain what various bits do. And the different ways to comment in Python, two of the most common ways in which you will use will be the hashtag style. So the hashtag style, you start a line with a hashtag, and then you write your comment, and that will continue to be a comment in grey in Spider until you start a new line, at which point, if you want to carry on, you'll need to use another hashtag. Or you can use this method, which is where you put 3 inverted commas in a row, and that starts a comment, and that will continue to be a comment across lines and across your code until you put these 3 inverted commas again. So be a little bit careful with that one. You can accidentally get into all sorts of a mess if you're not careful with that. But just be mindful that there are sort of 2 different methods that you can use for that, and both are handy for different things. But the key message is to leave comments for yourself and for others. Very, very important, particularly as you're training as well. So if you can get in the habit of doing it now, where it's going to be super useful for you, that will hopefully carry on in your programming journeys. Whilst you're at it, I'm just going to flag up something else as well that's worth pointing out. On your when you're in Spider, you'll see that there's a vertical line down here, and the reason there's a vertical line is it's good programming convention to not write extremely long lines of code. Now, back in the old days, that was because the screens, the displays that you're using were actually very limited. So it was to make sure that the lines of code didn't start spilling out into other lines when it was put on the display. Now, obviously, these days we can display things in 4K, 8K, and have increasingly large numbers of characters on the screen at the same time. However, that convention still remains, and it's still good practice not to write very long lines of text. So if I see any of you going over that line like that, then you'll have automatic points deducted. And there are ways in which you can split things over lines, and we'll show you that as we move through. But I just wanted to flag that up. So incidentally, if you were writing comments, and we were writing a comment here, if I ran out of space here, I should go down and carry on down here. Don't go over that line. It makes things very, very difficult to read. Okay, so we've talked about printing out things to the screen and grabbing things from the user, usually we want to do something with our variable values in some way. We want to manipulate them in some way if we're going to be creating a useful program. Now, when we're dealing with numbers, we're likely going to want to do some mathematical operations on them. And so we can conduct a variety of mathematical operations, from the very simple right to the very advanced within Python. So some of the very simple operations that we may want to do is to add things together, subtract them, multiply them, divide them, etc. And we can do this in Python in this way. And you'll see I'm using the comments here after. That's the other thing I should have said. You don't have to start a hashtag comment at the start of a line. You can put it at any point of the line, and from that point forward, it will then be a comment. So here, if we want to add two numbers together, we say, so let's imagine I've got two variables called a and b, and let's just imagine they're both integers. So a plus b will say add the value stored in a to the value stored in b. A minus b will say a subtract from a the value stored in b. If we want to multiply, we use this symbol here, the asterisk. If we want to divide, we use the forward slash here. So a forward slash b is a divided by b. I'll come back to modulus in a moment. If we want to say a to the power of b, like 3 to the power of 2, for example, then we use a double asterisk here to say a to the power of b. And that's how we essentially give something to the power of something else. Modulus, if you haven't come across it before, is a very useful mathematical operator, and it turns out to be quite useful when you use some modeling as well. Modulus basically says return the remainder after I've divided, after I say a divided by b, give me the remainder, give me what's left. Okay, so if I was to say 5 modulus 2, okay, well, 2 goes into 5 twice, but then there's a remainder of 1. So the resulting value from 5 modulus 2 would be 1. Now you might say, how useful is that? You will find out how useful that is. It's particularly useful when you do some modeling, as I say, and more will become clear as we go on. There's also these little shortcuts down here, which are really useful little shortcuts when you're programming. So if I was to put a plus equals 1, that's basically shorthand for saying a equals a plus 1. In other words, overwrite the value of a with a plus 1. And similarly, I could do that with minus 1, or it doesn't have to be 1. It could be plus equals 2 or plus equals 3 or whatever it might be. Now that's really handy, particularly when you're doing iterators, when you're counting stuff. So rather than keeping on saying a equals a plus 1, you can say a plus equals 1. So take the value of a and then add to it that value. And what it's doing is then doing this longhand version, which is saying, okay, I'm going to overwrite the value of a with whatever it was before, plus or minus that value. Now, on Thursday, we also talked a lot about conditional logic. And we said we could think of them as decision trees, where we want to do different things depending on whether something is true or not. So we might say, if this is true, then do this, otherwise do that. And we gave the example of me running out of cake in various levels of cake inventory shortage. So in Python, we can apply conditional logic using if, elif, else statements. So let's have a look at an example. Let's imagine that we want our program to print a different message to the user, depending on whether or not they're under 60 or 60 or over. So we might write the following, where we say if, and then we specify a condition. So here, and we'll come on to this comparator in a moment, this is saying if age, the value in age is less than 60, then we use a colon, and then we, in this tab indented block of text, and the tab indent is important, and Spider will automatically do this for you once you've written if age less than 60 colon, and you push enter, it'll automatically take you down to the right place. What it's the tab indent is doing is it's saying, if that's true, do all of this that's in that tab indentation. So in this case, that's just a single instruction that says, print, please go to room A. If that's not true, in other words, they are 60 or over, then we can use the else command, which basically says, if that's not true, then do this. And then in this case, it'll do everything in this block, which in this instance is just a single instruction that says print, please go to room B. So the key things here are the if statement, then the some sort of comparison. Now this comparison operator, this comparison statement must always resolve to a Boolean. In other words, this has to come out as true or false, because that's what it's assessing underneath. So age less than 60 is either going to be true or false. The age is either less than 60 or it's not. Okay, so this statement that must be resolved to a Boolean, followed by a colon, followed by a tab indented block of text saying everything you want it to do if that's true. And then we use the else statement to say if that's not true, followed by a colon, followed by this block of tab indented text of code to do this if that's not true. Now, I said about the comparison operator, and we saw here we used this to say less than. There are lots and lots of different comparison operators in Python, and the crucial thing is, if you're writing an if statement, they should, as I say, they should always resolve to a Boolean value of true or false. So one of the most common ones you'll probably use is this one. So I talked about the idea of using equals as an assignment operator. So we say a equals 3 doesn't mean is a equal to the value of 3. It means store in the variable a the value 3. If we actually want to say is a equal to 3, then we have to use a double equals. So we say equals equals. So a equals b means a is equal to the value of b. So if we were to say if a equals b in our if statement, we would then only carry out that block of code if the values of a and b are identical. Similarly, if we want to check, sometimes we want to check if something is not equal and do the inverse. And so to do that, we use an exclamation mark equals, and that means not equals. Then we've got the greater than and less than. So a greater than b and a less than b. And then you may also want to say, is it greater than or equal to, in which case we pop the little equal sign here as well. So this says a is greater than or equal to b, and a is less than or equal to b. And we can also combine comparison statements. So we can say, do this if this is true and this is true. So here I'm saying a is strictly equal to b and a is less than c. So if we put that in an if statement and we said if a is equal to b and a is less than c, it'll only do that block of code that follows if both of those things are true. So it doesn't matter if that's true, but then that's not true. That won't work. They both have to be true. If we only want it to be the case that the code is carried out as long as at least one of these things is true, then we can use the or statement, which basically says, do this block of code if either this is true or this is true. So if either of these resolve in a true Boolean, then that block of code will be carried out. Now, when we talked about decision trees on Thursday, we also said that there may be situations where we haven't got just a binary choice of if this, do this, else do that. Very often, we'll have multiple conditions to check. And so if we've got more than two, we can use the else if command, which is known as elif. And that basically says, okay, that may not have been true in the if statement, but maybe this is true. And so it's another comparison operator that we're checking. So here's an example. We may have, if age is less than 16, then print the message, please go to the children's room. Now, if they're not less than 16, we may still have different things to do depending on what the age is. So here I'm saying elif, age is less than 60. So if that's not true, then is the age less than 60? Now remember, if it's got to this point in the program, then the age is not less than 16, because otherwise this would have resolved to true, and we'd be up here. So we know that this is, we don't have to put here if the age is less than 60 and also greater than or equal to 16, because they must be greater than or equal to 16 because we failed that condition we've got here. So we know that that can't be true. So here we're saying if they're basically 16 or over but less than 60, then we go to room A, and then we use the else command to say if none of these things above are true, if you haven't got off anywhere else, then do this thing. Now, you don't have to include else. You may have some situations where you just say, if this is true, do this, but you don't have anything else because you don't want it to do anything if it's not true. And that's also fine. So the else and the elif commands are optional. The if is the only bit that you need to include. Okay, so I've talked for long enough again. So here's your second exercise. I'm going to give you a bit longer, so half an hour to do this one. So let's think about what you've learned so far. You've learned how to print to the display. You've learned how to request and store inputs from the user in variables. You've learned about different variable types and how to cast variables to turn them into different variable types. You've learned a bit about mathematical operators, how we do mathematical operations within Python. And you've learned about how to use conditional logic using if, elif, and else statements. So what I want you to do is switch to Jupyter Lab, and you will have a file called python_prog_workbook_1. I will bring that up now so you can see it. Switch over. So this will open up in your web browser, and it should look like this: Python Programming Workbook 1. And basically what you've got here, hopefully you'll be familiar with Jupyter Lab if you watched Mike's videos, is a series of 4 questions. So we've got a combination in Jupyter, in the Jupyter notebook of markdown text, which is this explanatory text here, and then little code blocks here. And here we can write and run blocks of code. So what we want to do here is to write a simple calculator in task 1 that asks the user to input 2 numbers, then adds them together and displays the result to the user. So you'd write a block of code in here that does that. So this isn't the answer, by the way. Let's say it's age equals 56. Now, if I push Control and Enter when I'm in that code block, it'll run that. So now it's got stored the variable age equals 56. In the second block, I want you to write code that checks whether the output of the calculation above is 1 million or more. So whatever comes up here, if that result of that calculation is 1 million or more, it displays a message to the user saying, wow, that's a big calculation. So if you haven't already, you'll need to make sure that the result of the calculation you store in task 1 is stored in a variable in order to allow you to do that. In task 3, you're going to write code that asks the user to input the length, width, and height of a cuboid in centimeters. If all 3 of those measurements that are input are the same, then the program will identify the shape as a cube, it'll notify the user of this, and it'll calculate the volume simply by cubing one of the measurements before displaying the volume to the user. If all 3 measurements are not the same, then the program will tell the user this is a cuboid and calculates the volume of the cuboid before displaying the volume to the user. And then in the final task, which is a little bit more challenging, so think carefully about this and ask each other for help if you need to think this through. I want you to write a piece of code that asks the user to input a day number from 1 up to and including 365, and which, assuming that day 1 represents a Monday, prints out the day of the week corresponding to the day the user inputs. So for example, the user were to input the number 16, the code should print out Tuesday. So that's a good test to see if it works. If you type in 16 and it prints out Tuesday, you've probably got it right. Think carefully about how you would do this. It takes a little bit of lateral thinking, but there is something that I've shown you so far that will allow you to do that. So it's a bit of a creative problem, and say do bounce ideas off each other if you need a bit of help with that. So it's 22 now. I'm going to give you half an hour plus a 5-minute comfort break. So we will rejoin at 11:15. I think there's a couple of you having problems with being able to get into Jupyter Lab. If that's the case, I will put a screenshot of these tasks op in the Slack workspace, so you can see what the tasks are. And you can then write these things in Spider. But if you've got Jupyter Lab all up and running, then do run it in that. Okay. Any questions about any of that? No? Fantastic. In which case, have a go at that. Remember to use your peer support groups if you need help. And if you're all stuck, to contact us. And I will see you. Make sure you take a 5-minute comfort break at least as well to stretch your legs. And I will see you at 11:15. Fantastic. See you then.